Hello, my name is Darren Thomas and I am the Director of Educational Research Techniques. In this particular video, we're going to be looking at fraud detection again with Python, but we're going to be combining two different concepts that we worked with in past videos, SMOTE and logistic regression. So let's go ahead and see what we can learn. And so essentially what we're going to be doing here is SMOTE is a type of sampling technique, whereas logistic regression is an algorithm that we can use to try to detect fraud. And so by combining these two, you can potentially improve the accuracy and the strength of your model that you're trying to develop. And so why don't we go ahead now and start putting in our various libraries that we're going to be working with. So we're going to be doing that first. So you can see here we have a lot of information that we're going to be using here. So these first two right here, this is for imbalance learning. These are going to be involving using SMOTE and pipeline. We'll talk more about pipeline in a moment. Pandas is right here, of course, and NumPy. That's for data preparation. We don't need matplotlib, so just ignore that if you will. It won't break anything if it's there, but we don't need it. Of course, we're going to need logistic regression. That is our model, our algorithm that we're using. Train test split is what we're going to be using for separating our data into training and test sets. And then confusion matrix and classification report is for checking the metrics that will help us to assess the strength of our model. So we're going to go ahead and run that. Okay, so next we're going to go ahead and take a quick peek at our actual data, just for those who may have not seen prior videos. So we're going to go ahead and paste this in. We named our data set df.head. In case you're wondering, this is the code right here for actually loading our data. We're using the .read underscore CSV method, and data location, that is just a string that contains the actual address of the data as it is found on my computer. This data is not openly available on the internet per se, just on my local device, and I saved it as a object here. So we're going to take a look at this, and so you can see we have we have more than 5 rows, but you can see 5 rows, and we have 31 columns. All that information is down here. And so the variables have no names, so there's no way to really interpret what the model is doing. This is kind of nonsense data. So we're going to take V1 all the way to amount as our X values, and then the class is telling us if that particular row is a case of fraud or not. And so 0 means it is not fraud, 1 means that it is fraud. So that's what we're doing there. Now, as I kind of alluded to, we're going to separate our data set into 2 objects. One object is going to have our X values, which is going to be variable 1 all the way, I believe, to variable 29 plus the amount variable, so 30 altogether, or something like that around there. And then we're going to also have another object called Y, which is going to contain just the class, which was the last column in our data set. And we're also going to convert these into a NumPy array as well for the purposes of our model. So here's our data right here. So X values is going to be all rows. That's what this colon means right here. And we're using the iloc right here. It looks like method or function, whatever you want to call it. And then after the comma, we're taking columns 1 to column 30. So remember that Python is 0 index. So this first column is 0. We don't need this. This is like an almost like an ID, if you will. So we don't really need that first column. And so we're taking basically the second column all the way to column 29, because you don't include the last number when you are doing things in Python. That's just the way it is. And then of course, we're going to change our X values into a NumPy array, and with a float as a type of data type. And then of course, we're going to repeat this process, but this time we're just going to take the last column here, column number 30. We're going to take that because that's where our class values are at, whether it's fraud or not. We're going to make that its own NumPy array as well, and that's pretty much it. And so if you wanted to look at these, you could. There's really no point. But in case you're curious, we're just going to print some of this. That's what the X values look like. You can see that. That 1.725 is this guy right here. So we know we're good. And then we could do the same for our Y's if we wanted to. And you can see this first 0 is going to correspond to this guy in the first row right here. So we're looking like we're pretty good here. Now we have to split our data into train and test. Because we're training a machine learning model, we have to train our model. And we have to assess how well the training went. And this is why we separate our data into train and test sets. So we got to have training data for our X values and training data for our Y values. And the same thing for test data as well. And so what we're going to do is we're going to split it at a 70-30 clip, which means 70% of our data will be used for training and 30% will be used for testing. That's what we're going to do. And so let me just show you the code for this. Here we go. So we're making the 4 objects. Notice how there's 2 that are testing, 2 that are for the X values, and 2 that are for the Y values. I've already mentioned that. And so let's go ahead and see how this works. We have our train test split right here. We're taking our X and our Y objects. Test size is set to 0.3, or you can say 30%. That's how big the test data is going to be. And the random state is like where you set the seed. So this is to allow you to reproduce your data set, or reproduce your results, excuse me. And so that's kind of what's happening right here. And so another point I need to make is that you're only supposed to use your testing data one time. We're going through the whole process here. If you wanted to retrain your model, you would of course do something like a cross-validation, k-fold, or whatever you want to do. It all depends on the situation, but that's how you would do that. So we're not doing things exactly how you might find it in the real world, but we're doing it close because we're only going to look at training our model just the one time, which is normally not how it is done. Now we're going to the pipeline development. This is a little bit different compared to maybe how you've used Python code before. And so what's happening with the pipeline is it's probably better if I show you a picture or put the code out there first. That might help. We're going to pipe in what we need here. Again, this will make more sense in a second. So let's take it one step at a time. All right, first we're going to create an instance of our SMOTE. Now SMOTE is for resampling. And so SMOTE stands for Synthetic Minority Oversampling Technique. And so we use this when there's an imbalance in the cases that are available. So normally fraud is very unusual, less than 1% of your data. And so it can be hard to train your data when you have so few positive cases because random guessing is enough to have, 98, 99% accuracy. So in order to improve that, they've developed something called SMOTE, which is where they take your actual cases and they make synthetic examples of that in your data set so that you have more data that you can use that are positive cases. And so this is great for training a model, but it's bad for testing a model. You don't want to test your model on synthetic cases. And the synthetic cases are made through using something called nearest neighbor. So again, without making it too complicated, if one example is considered a positive case, the computer might make the assumption that values that are near to it are also examples of positive cases. And so that's how you're able to balance it out. We looked at this in a prior video where we started with 5,000 cases altogether, and maybe like 15 or maybe 50 of those were positive cases. And through using SMOTE, we ended up with 10,000 cases where you kind of had half and half. You had 5,000 positive cases, 5,000 cases that were not positive, or you could say negative. And so that's kind of what's happening with SMOTE. And so we are creating an instance of this and calling it resampling. Now with the model, we're just creating an instance of logistic regression, and we're setting the max iterations to 1,000 to make sure that our model converges. Again, the detail behind convergence is kind of beyond the purpose of this video. And now we're getting to the star of this particular section, and that is the pipeline. And so if you're familiar with R, piping code is very, very common, very, very popular, with the Regression package, where you set things up and then you pipe the previous results into whatever you're doing now. You continue that piping. very common if you're using, like, ggplot2, dplyr or whatever. And so this is kind of an example of this in the context of Python. And so what's happening right here is that I'm using the function called pipeline, and I'm taking my sampling, resampling object here, and I'm putting it inside here, and I'm just calling it SMOTE. This is like a tuple, if you will. And then I'm taking my other thing that I want to do, and that is I'm going to pipe my resampled data into my logistic regression model after the comma right here. This is kind of like my second tuple. And then notice how all this is captured inside brackets as well. So that's kind of what's happening here. So let's go ahead and run this and see what happens. Well, nothing's going to happen, just in case you're wondering. If you really are bored, we can take a look at it and just see what's inside it, but it's not that exciting. That's it, nothing to see. All right. So now we can actually develop our model, but we have everything set up as we desire. And so you can see, one thing I need to mention, notice how it says steps right here. So the first thing is SMOTE. You can see that right here in the output. And then the second thing is going to be logistic regression. That's what's happening right there. All right. So let's go ahead and do the next step. And so this is something we're already familiar with. So now we're going to actually develop our model. So I'm taking my pipeline, which has the SMOTE information right here and logistic regression right here, and we're going to fit the model to it using our training data. And then from there, we're going to make our object called predicted, and we're going to take our pipeline model now, and we're going to predict using the X test values. So that's the data we set aside to test our data so that we can make our predictions here. That's what's going on. So we press enter. Again, there's nothing to see yet. The good stuff is coming at the very end. And so now it's the moment of truth. We're going to assess the performance of our model. And so what's happening here is we're going to print out our classification report, which is going to give us our various scores, precision, recall, and F1, also the accuracy. And notice we're using the classification underscore report function here. And then we got our Y test. So these are our actual values from our data, Y test. And then we're going to compare the Y test to the predicted values we got in the previous cell here. Then the confusion matrix is the same basic ideal. We're going to compare our true values. We're going to compare those. We're going to set those to Y underscore test. And then our predicted values are going to be set to predicted. And we're going to, again, assess that. So we're just going to go ahead and press Control Enter, and you can see right there. So here are the results. Again, the details behind precision and recall are in prior videos, but they're just trying to assess an ideal of positive negatives compared to false positives or false negatives, all that stuff like that. And so you can see our precision is maybe that's good or bad. It depends. I believe precision has to do with false positives, and this is down here false negatives. So I think this is false positives. Recall has to do with false negatives, so you can see we're pretty good at that. And then the F1 score is kind of like a balancing between the precision and recall. So you can see we're doing a pretty good job here, but it depends on the context. Notice how we have here, these are our true positives right there. So they got 9 of those right. And then we have a handful that were incorrectly classified, as you can see right there. Now, is this better than what we got? If you remember from a prior video, we did the same exercise without SMOTE, and I have those results right here so you can see. And you can see that our model was actually a little bit better when we did not use SMOTE. You can see we have one less false negative up here, I believe, or is that a false positive? I think it's false positive. We have one less, so here, last time we had 2, now we have 1. So in this situation, SMOTE might not be the best, but you can see the numbers are so similar that it's kind of hard to, complain too much. But that is how this can be done. So SMOTE is not a smoking gun, no pun intended, or a silver bullet, but it can be useful in some situations. In our situation, it hurt things a tiny bit, not enough to raise a red flag, again, no pun intended, but you can kind of see the process behind this. So let's go back and summarize what we did and wrap up this video. So in this particular video, what we did was we looked at how we can combine the power of SMOTE, a type of resampling, with logistic regression, an algorithm that can be used to detect fraud. And so we started the course by loading all of our packages, or excuse me, libraries. We took a quick peek at what our data looks like. Then we set up our data where we separated our X values from our Y values so that we could train our model appropriately. Then we split our data into train and test, because you have to train your data on one, you have to train your model on one piece of data, and then you have to test your model on a separate piece of data. From there, we got into SMOTE, how it is used to create synthetic examples to help to improve your model's ability to detect fraud. And then we learned about the pipeline, which is used to have your code follow steps sequentially that can be used for the purposes of predicting with your model. Then we've done what is traditionally called model development. We've seen this before. The only thing that was unique is that we're using pipeline here instead of model. Normally we set up everything using model.fit, but we use pipeline because of the multi-step process that was involved. And then we looked at our metrics here. And so you can see our numbers are pretty good. We just had one guy up here extra than normal in terms of, again, false positive, I believe, or false negative. I always get those confused. But you can see that our model is pretty good overall. And again, even though SMOTE did not improve our predictive power, knowing that something is not the best way is also useful knowledge. So if I were to continue to analyze this data, I would probably not use SMOTE unless I found some other way to make adjustments to my model to improve things. Maybe removing some of the variables. They're not useful in terms of predictive value, etc. But that's beyond the scope of this video. So again, I want to thank you so much for watching. My name is Darren Thomas. I am the Director of Educational Research Techniques. You take care.